Hi everyone. I just wanted to illustrate the way that Topologic now can communicate with a Neo4j Graph Database, and in this case it's also hosted remotely using something they call, I think, AuraDB, AURADB database. So what you see here are two instances of Blender with Topologic running in each of them. Obviously, one of them could have been on a completely different computer, in a different location. The one on the left that is more like a wireframe and green, like this one, is the author. Basically, it's the one that is creating the building and creating the graph. And the one on the right in this translucent blue is receiving the data and just simply updating the view from the remote database. So the virtual graph basically connects using credentials here and the URL, as you can see here. It's a special URL to go over to the network, and it has the username and password, and it creates a graph, a Neo4j graph. And what I do then is I'm creating some prisms, a couple of prisms here, some topologic prisms, intersecting them to make a cell complex by cells, and I'm making a graph by topology, which is this yellow wire that you see here that connects the centroids or the internal vertices of cells to each other. And I'm saying go through the shared topologies and also store the boundary representation. So actually store the geometry in those vertices. So every vertex that you see here has a copy of the topology, the parent topology that created it. And then I basically, just so that I don't have multiple graphs, I delete everything that is pre-existing in this Neo4j graph, and I add a new one which is coming from my topology graph right here. And all of this is just simply drawing the stuff so that you see them on the screen. And that's the output, is that it is being sent. So this graph now has been sent to the cloud, to AuraDB, and if I just update this view here, this is the graph that exists on the remote connection. That's the one here. And if you count the number of vertices, etc., and if you look at the brep and the type, so this is a cell, this is a face, that's a face, this one again, so you can see how they are all connected. So that's one cell, this is a face, this is a cell. Great. So so we can go ahead and exercise this a little bit. So I'm going to go ahead and re-update this. Actually, I don't need to. I'll just change some geometries. So let's go ahead and change some dimensions just to see it update. So this is length 5. Let's make this length 3, for example. Let's increase the height on this one. Let's make that 4. Okay, so that's a slightly different geometry. So I can go now to the right side and re-update the nodes, and it will get this new geometry from the graph. But before I do that, let me just show you that hopefully the graph here has changed. Maybe the topology has not changed, so it might still look the same, but these breps would have changed inside here. So this has been now updated remotely. I can go here and click re-update all nodes so that it will read the graph and gets a topologic graph by Neo4j graph, gets the vertices, gets the dictionary of the vertices, and looks for a key in there called brep, and that has the actual brep information, as you can see here, and basically then create a topology by those strings. And as you can see here, I have cells, 1, 2, 3, 4 cells, and then I have several faces that are shared between those cells. So let's go ahead and update this. This might have been the one before, so let's go ahead and update it. And it will take a few seconds to bring it in, but you can see it's not instantaneous because it's going to the network, grabbing it and bringing it back. So here goes. and it has updated. And there it is. Thank you.